Hi gents, this is Mr. Holding here. This quick video is just looking at contour maps and then a couple of terminologies around them. So contour maps basically give us, they're a 2D representation of 3D. So you're probably getting used to looking at maps and you forget that we've also got to work out that there's variances in height, and contour maps allow us to do that. Okay, so they do that by what's called contour lines. Now, contour lines, if you look at page 361 of your textbook, if this is the map here, these lines are contour lines. And basically what they represent is that anything along this line is at the same vertical height above a datum. Now, in most cases on these kind of maps, it's with reference to sea level. So, for example, this one's a map of a contour map of Mount Crosby. And there's different lines here. So this one here you'll see has 195. So everywhere on that line has been surveyed to be 195 meters above sea level. 190, this one here, everywhere along that line is 190, 185, and so on. Now you'll also notice another thing here is that the distance between them is consistent in terms of numerical value. So everything on here is 195, everyone here is 190, 185, this one would be 80, 175. Okay, now that's consistent at 5 meters, and that's known as the vertical interval or the contour interval. Okay, and that allows us, so there's a couple of terminologies to start off with. Next thing to have a look at is what's known as the profile. Okay, so the profile is like a cross-section cut in between two particular points. So in this case, we've got, and this is the our contour map, we want to do a profile between, straight line between A and B here. Now this down here is a graphical representation of that, and basically if you were to cut this land in half and look at it from the profile side, this is how it would look. Okay. The other thing to consider as well is that what we often have to do is do what's called a vertical exaggeration, and I'll go through how to do that. And vertical exaggeration basically allows us to exaggerate this particular curves. Now, what we might see is if this was over, this is a rise just from here to here of 20 meters. Now, if that's over 20 kilometers, that's not a particularly steep rise. If it's over 50 meters, however, that is quite a steep rise. So depending on what it is, over long distances, we add this vertical exaggeration to really show those undulations and different changes. Okay, because if we didn't do that, it would actually appear quite flat, and you wouldn't really notice that there is a change in heights. Okay, so that's another thing, is the notion of profile view. Okay, and this idea of vertical exaggeration. And so exactly how to do the vertical exaggeration we'll do in another video. But the other one I wanted to look at was the term gradient. And so basically, hopefully you've heard the term gradient before in both mathematics and science, geography and some other subjects as well. But basically the gradient is how steep something is, all right? And that's calculated by the difference in the height, or the change in height, over the horizontal distance in which that change in height occurs. Now, another way to reference that is the rise over the run. So how far it goes up over the distance in which that rise occurs. Okay, so obviously either the steeper it is over a distance, the greater the gradient, or the shorter the distance that the rise happens, the greater the gradient. So either of those two things. Okay, so there are so far three key terms you need to look at in terms of contour lines, vertical or contour intervals, vertical exaggeration, and gradient. Okay, so I hope you found this helpful.